Hi class, this is Professor Yu. I want to talk to you about the project number 5 for macro PChem. This will be the last project that you will be working on, and thank you for your uh, time and patience to come to this final end. And so this project is about the kinetics. We are talking about A goes to intermediate to the product, and then I want you to essentially prepare the plot. The plot for case 1 and case 2. These are the two cases. And then I want to put you as a function of A, which is a reactant, I intermediate, P as a product, and all of them following the consecutive elementary first order reactions. So your first x-axis is a time, y-axis is a concentration normalized by original concentration of your reactant, and so that's what we call normalized concentration for three components. So it's J concentration over A naught, but J can be A or I or product. And as same in the table, the initial condition, A is an A naught. There's no initial condition whatsoever for intermediate and the product. And also you can use the fact that the concentration for this remains to be constant because essentially either A decompose into the I, further decompose the P. So number of moles remains to be constant, and so there's no concentration to be same throughout. That actually became very handy for us to calculate. So if you're looking at the textbook, the equation is being provided here. The A concentration is a simple decay. I intermediate concentration is a decay of two different constant with different rate. And then the product is actually can be simply calculated. I will show you later. You can use this equation or you can use a very simple equation at the end. I will show you. But the first problem, the case 1, is a Ka is a 1 per second, Kb is a zero point 0.1 per second. So 1 versus zero point 0.1, so there's 10 times differences. This is exactly the case when Ka value is 10 times the Kb value. And then I want you to plot as a function of Ka, and not Ka, but just the time versus the normalized concentration. And you will generate those three curves using this equation shown below. Once you make an Excel sheet nicely, you can actually simply change these numbers to any combination that you like. And here is an opposite case where Ka value is smaller than Kb value, and you can essentially make the plot shown up here. So I am going to also put you to um, the the template. And so this is a template that I'm going to put it to you. And so I want you to put your names and VIN numbers for the submission. And that's the one that I'm going to put it in. And this is an initial concentration. And the K and A value can be changed from here. So you can change your K and A values for your simulations. And then the delta t, which is a timetable, because it is actually, I decide to change the value, increment of 20% in each. So if you look at that, the first one is 0 second, second one is my choice, 0.005 seconds. Other than that, and this one is this time multiplied by 1.2, which is a 20% increase. So does this. So this data is in a log scale so that you can go up to the 30-second value within a reasonable time. So I'm kind of using the modified log scale so that we can generate the plot to see if we can make the data looks like that in a more reasonable computing time. So I will provide even time axis for you, and you just need to calculate A and I and the p values following these notations. Okay, so here is actually, I have made this one my own calculation. So if you look at that, that is just simply the A value is just nothing but initial concentration, which is a 1.0, and then exponential to the minus KAT. So I calculate those values. And then what about the I, which is using this expression? And so you can plot those. And the P is something that is interesting, that if you look at the way that I do, I didn't use this expression. This expression is actually the fact that it is total concentration minus concentration of A minus concentration of intermediate at any time. So that will be the way that you're going to put it in, and then you're going to compute these values, and then throughout the time you can get this value. And just to check it, throughout those time, any time period, the concentration of A and I and the P summation should be same as the original concentration, which is what I did is, if you look at my table, it's just a summation of these three values, and just to check that it is true. And once you calculate those numbers, and you will see that this one shown up in the bottom. And let me bring this one up so that you guys can see this one when I change that. So once I have this one made it up here, and what I do is I'm changing my k values. So I can change k values in any way that I want. So if I change this one to be something like 5, this one changes like this, and so that I can predict those time dependence of variable. For you to answer those questions, so this is a case one. Case two is, I think that this KB value is 10, and you will see that the value is changes like this. So what I'm looking for from this assignment. Is okay. So this is a case one, and also I want you to, for the last time, I want you to check your ability to see whether you can change the series values here. And the way that you can change the series value, which is a legend caption, is the following. So you double click on it, and you see the select data column. So this is the way that it works funny. Okay, so the select data column, the series A, which is now you are going to edit the series name as being A concentration. And series B, you double click on it, and then the edit, that's your intermediate concentration. And series C, that's edit, and that is your product concentration. Let's see how I change my case, and then this is how I change my case, and then it worked pretty well, I think. Right? So that's a concentration of A and B and so on. I go here, and maybe I can make my font a little bit bigger so that it's easy to be seen from the one. So that's a case one. I still need to want you to put down the values or the legend axis. So go to the chart tool and go to the chart element, and axis title in x-axis title is t, which is a second. Okay. And then you go to the chart element, go to the y-axis. So this is under chart tools, so design, and then you can just see that that's an j divided by a naught. Those values. I think that these texts are overlapping, so you just give a little bit of the room and to make sure that you have those values in place. And so once you finish this, what I want you to do for your homework submission, this is, I guess, you can just go and click on the copy, and then you can use paste special, or paste special as a one, and so that you can have, okay, this is a case one. What about the case two? You go here and change the value to 10, right? Keeping the everything is the same, and then you'll find yourself to be fixed here. One thing that you guys need to notice that because of the way that I put it in, here if you click on this x-axis and click on mouse route right mouse button, and you can see the format axis. I can designate the time scale for the x-axis from 0 to 30 to be exact. Otherwise, you have a floating spaces, something. So, for example, if I were to change it to 20, okay, and if I do that, you will see that this number is changing to 20. And so therefore, I don't want that to happen. So I wanted to I want to compare an apple to apple for two different cases. So I wanted to make sure that the x-axis is ranging from 0 to 30 seconds. And the y-axis is, if you click on here and the format axis. Here I chose to actually ranging from minus 0.2 to the 1.0. That's your y-axis, and that's what my point. And then so I guess I need to go up and double click on this title, and this is a case two where I can make this one happen this way. And all I need to do is for before I finish my this, and this will be copy and go here, and you can go to paste and then paste as a picture. Now I think that you have demonstrated that case one is this answer, case two is this answer, following the same axis labels and the same ranges. You can see that one is a case where you have a significant buildup, the intermediate, which eventually decays away, whereas this is a case where you are seeing this intermediate was quickly decays away, and then things are essentially reaching the product, and you'll see the not many significant buildup within the time scale that we see. Okay, so once you have that, you can say put your names in and submit these two figures containing those, and that's what I mentioned here when I say the project number 5. Okay, so the case one, the case two, and then you can submit this one through the Excel sheet in the assignment that I'm going to post it on LMS, please. Thank you for your attention.